Donald Rump is a milkshake mogul who has a very successful milkshake store in the middle of downtown New York. Recently, he has had trouble with people sneaking into his store and stealing his milkshake supplies. He calls these thieves milkshakins. Donald Rump wants to build a fence around his milkshake store so that the milkshakins can't steal his milkshakes anymore. He has 1,000 feet of fencing. The dining area is rectangular and has a semicircular bar area on the other side. What dimensions of the rectangle and what radius of the semicircle will maximize the dining and bar area, but at the same time provide the store with the most effective fencing space?
First, we set up the perimeter and area equations, and then we solve for y. Then what we did is when we solved for y, we plugged it back into the area equation. All that's happening now is we are writing out the equation with y plugged in to the area equation, and what's going to happen next is we are going to take the derivative of the area equation with y plugged in. What's happening now is he is taking the derivative of the area equation with y plugged into it and setting it equal to 0 to find the maximum of r. What's happening now is now that we have r, we were able to plug it back into the perimeter equation and simplify and solve for y. Now that we have our r and y values, what's happening is we are plugging the values back into the area equation. And what this gives us is the area of the space and the store surrounded by the optimized fence.